Okay, so it's good to see everybody. Hope you had a good weekend. No, coming up this weekend, we have another 3-day weekend. Okay, if you weren't aware, there's no school next Monday, so you get another 3-day weekend, which is always nice. So next Friday is the end of the 9 weeks, so please just be thinking ahead. In fact, it looks like this test coming up on Wednesday is the last grade of the 9 weeks. So please prepare for it. Try to do the best that you can. Yes, I will get that to you in just a second. So speaking of the exam, it's going to cover the sinusoidal models like the quiz that we had last week. It's also going to cover the 2 lessons over graphing all the trig functions as well as the transformations. So hopefully folks are making their 3x5 note cards. Does anybody need one? Okay, got a couple over here. Okay, there we go. Let's pass one back there. Okay. Doing this. Anybody else? Yes, that material and the 2 graphing lessons where we have the transformations. Sine, cosine was the first one, and then the other 4 was the second one. Anybody else? Okay. All right. There we go. If you pass that back, please. Okay. Now, one thing I would go ahead and encourage you, whatever you want to write on there is definitely fair game. Now, while we talked about it, it's been a while, so you may or may not remember. Be able to tell the difference between an even and an odd function, like what the line of symmetry is going to be. Okay, I would definitely have that on your 3x5 note card, or at least make a little note to look that up sometime between now and Wednesday. Let's see here. This is an oldie but a goodie. We haven't brought this up in quite a while. Badges, please make sure that your badges are visible, whether it's around your neck, it's on your person, it has to be visible. And remember, it's a safety issue because, perfect example, I don't know if you were aware, this past Friday morning, we had 4 guys just walk in off the street right into the dining hall. Okay, so luckily some teachers saw them, were like, hey, what are you doing here? Who are you? And went from there. But please make sure that you got your badges visible so we know who's supposed to be here and who's not. That is the very first lesson of the year. No, it does not have right triangle trig. And on Thursday, of course, you got the PSAT, so remember to bring your charged Chromebooks, get yourself a good night's sleep, all that good stuff. They have not released the schedule yet, so as soon as they do, I will pass that information off to you. Hopefully it's going to be sooner rather than later, but that's one of the lessons. So it's the 2 lessons where you're graphing all 6 trig functions and the sinusoidal models. 3 lessons. All right, I think that's all I got, unless anybody has any questions. All right, well, we already needed one of those. There we go. Did anybody else need a packet? Okay, so I'm going to go ahead and give you a heads up. I'm going to start making fewer copies of these. So if you're one of the people who constantly asks every day for a brand new packet, you're going to want to learn to either get a binder or someplace to keep this safe, because I'm not going to have copies. Okay, please start keeping track of those. All right, well, let's go ahead and get started. Now, we're not ready for the compositions just yet. We will get there, and we're going to spend time on those. But I believe it was last Thursday when we went ahead after the quiz and started talking about all the different aspects of inverses. We were kind of remembering a few things. So did anybody have any questions over that material? It's been several days since we talked about it. Okay. Yes, you just take the x's and the y's and you reverse them. So the x values become the y values, and the y values become the x values. Our line of symmetry is the linear parent y equals x. That's what you reflect anything across if you want to see what the inverse looks like. Okay. Well, let's go ahead and get right into it. Let's start talking about sine inverse. But we have to go ahead and first try to figure out why we look at sine inverse the way we do. So it says plot y equals sine of x on this interval. Now it says from negative 2 pi to 2 pi, so this grid, first off, it's not a perfect grid to begin with, but it's definitely not going to go from negative 2 pi to 2 pi, but we'll go ahead and fit in as much as we can. Did sine start with a 0 or a maximum? 0. So 0. We have a maximum, 0 minimum, 0. So I'm going to go ahead and just fill this in. go in the opposite direction as well. Okay. So let's say the highest value is 1. The lowest value is -1. Let's say this first unit right here represents pi over 2, and this one right here is -pi/2. Okay, so there's the graph assigned, nothing new, and we've seen that for quite a while now. But the question says, is the function 1-to-1? Now, for 1-to-1, remember, we're going to use the horizontal line test. So I'm going to take this horizontal line and I'm going to sweep it up and down. Am I ever hitting the graph in 2 or more places at one time? Yes, so this fails the horizontal line test. That means it's not 1-to-1. Okay, so let me go ahead and get that out of the way. So remember, the horizontal line test is a visual way to see if any values of y repeat. Okay, now remember, for inverses, that's huge, because what are we doing with the x's and the y's? We switch them. So if we have repeating y values, and then I take the inverse, those repeating y values become repeating x values. In fact, if I were to take the inverse of the function as it is right now, okay, it's going to look like this. You'll notice the vertical values of -1 and 1 are now horizontal. The horizontal -pi/2 and pi/2, they're now vertical. So if I went ahead and took a vertical line and put it through, this is definitely not a function. And it's really, really super important to us that our inverse be a function if we're going to be able to answer some questions using it. Okay, bro? You forgot? Okay, that's okay. If you remember, let me know. Now, here's what we're going to do. Because this original graph is not 1-to-1, we're going to cut away parts of it so that what's left is 1-to-1. We call that restricting the domain. Okay, so let's run through these questions, and that's going to help us get an idea of how to do this. First off, the range. So what's the smallest y value to the highest? What's the lowest the graph goes? -1. Okay. And what's the highest? Yeah. So did everybody agree the range of this graph, it's between -1 and 1? Okay, it only oscillates between the two? Okay. Now, what domain value, remember when you see the word domain, we're talking about the x's. So what domain, x value, will give you a range, y value of -1? Now what we want to do is choose points close to the origin as we can. So I'm going to choose this point like right here, because this point has a y value of -1. What's the x value though? -pi/2. Because we want to choose values of x that are going to fit with the range that we have here. So now here's the other question. What domain x value will give you a range y value of +1? So for this one, we're going to use this point. Because right here, there's a y value of +1. But what radian gives me that? pi/2. Gabriel? Oh, this is not on the test. Oh, eventually, yeah. See, not on one of mine, but I can't say what could possibly be on the AP exam. That's why I would be as familiar as possible with not only what the inverse graphs look like, but also what their domain and range are going to be. Because we've seen not all the problems have a lot of math involved. Really, some of it might just be knowledge of that concept. Okay. So, I mean, we'll see as we get into May. We'll see how that works out. Okay. So using these 2 points right here, we're going to cut away the left side and the right side right here. By cutting away those parts, we call that restricting the domain. Okay. See, now, if I were to go back, if I took my horizontal line and I sweep it through, am I ever hitting it in 2 or more places at one time? No. So this is 1-to-1. That means the inverse is going to be a function. Okay, so let me go ahead and list the domain and range as we have them right now. So the domain, horizontally, it only exists between -pi/2 and pi/2. The range, okay, vertically, it only exists between -1 and and 1. Okay, now we're about to take the inverse. Remember, the x's become the y values, and the y values become the x's. So this domain right here, it's about to become the range of the inverse. This range right here is about to become the domain of the inverse. Okay. So let's go ahead and plot this. You'll notice how negative pi over 2 and pi over 2, those are horizontal. They represent x's, right? Well, on the inverse graph, now they're going to be vertical. Okay, so let's go ahead and say, let's go 2 units for each one. Let's say negative pi over 2 is right here, and pi over 2 is right here. Oh, I forgot to put in pi over 2 for that one. Okay. Now look at the graph up top. You'll notice vertically we have negative 1 and 1. So the range, the y values are now going to become your horizontal x's. So let's say this is negative 1, and that's a positive 1. That hurts them. Okay. Now, we also have a couple of points that we could go ahead and invert as well. Remember, any point on a function, if I have AB, that becomes the point BA on the inverse, right? So let's take this first point right here. If I originally have pi over 2 comma 1, what would that point be on the inverse? Remember, we're not changing the signs, we're simply switching their positions. So pi over 2 comma 1 would become what? 1 comma pi over 2. So from the origin here, I'm going to go 1 to the right, pi over 2 up. So there's 1 pi over 2. What about this point right here? Negative pi over 2, negative 1, what would it be on the inverse? Negative 1 and then what? There you go. So this point right here would be negative 1, negative pi over 2. All right. Now remember, any graph that I want to see the inverse of, I'm going to reflect it across the line y equals x, that linear parent graph. Okay, so for this one right here, if I were to go ahead and reflect it across the line, what looks like an elongated S, it's now going to look like this. Okay. Now this isn't going to be perfect, but hopefully we can kind of get an idea that when you go ahead and do that, it's going to reflect perfectly. Unfortunately, like I said in the beginning, this isn't a really good grid to begin with. The unit measurements aren't consistent, which is why it's off there a little bit. Okay. But at least this gives me an idea. I should know exactly what sine inverse looks like. So I'm going to start here at the bottom left. I'm going to curve up to the right. This is the graph of sine inverse. The sine inverse of theta. And you'll notice how wide is it? What's its domain? How far left and how far right does the graph go? Ella, what do you think? Negative 1 to 1. Okay. And the range? Liam, how tall is it? From what to what? There you go. Negative pi over 2 to pi over 2. See, exactly like I said, the domain up here became the range on the inverse. Okay. The range up here became the domain in the inverse. We're just switching the x's and the y's. Okay. All right. And that's what these blanks over here are just kind of emphasizing. Then horizontally, it's now between negative 1 and 1, and vertically, it's between negative pi over 2 and pi over 2. Okay. So questions on that? Gabriel. What do you mean? Now, we can transform it, but this is what sine inverse is going to look like. So, like, I can stretch it vertically by a factor. I mean, I can shift it if I wanted to, all kinds of stuff. But now, looking at big picture, once we know what sine inverse looks like, here's what we really want to focus on. We can only evaluate an inverse trig function with a ratio. 2 sides of a right triangle, and my answer is going to be the angle that belongs to that same triangle. Well, because we have the domain and range, That means your ratio can only exist between -1 and 1. Like, for example, give me a number that's outside of that interval of -1 to 1. Felipe. 2. So if I tried to evaluate sine inverse of 2, I can't do it. It's undefined. The only way I can evaluate is if it's in this ratio, or it's in this interval, I should say. And then your angle measure has to exist on this interval. It has to be from -π/2 to +π/2. So if we're thinking about the unit circle, and remember, everything always ties back to the unit circle. That's where everything begins. Sine inverse can only exist in quadrant 1 or quadrant 4. It can never exist in quadrant 2 or 3. Now, you remember that little green line that I've got highlighted right there, the positive x-axis? Does anybody remember what we call that? 2 words, starts with an S. It's been a while since we've heard it. Peter, what do you think? Whoop. Standard position, yes. We always start rotating from there. Okay, so from standard position, you'll either rotate counterclockwise into quadrant 1, or you'll rotate clockwise into quadrant 4. Now, some interesting facts here. Sine inverse can only give you an acute or a right angle answer. Basically, it's got to be acute or 90 degrees, π/2. Sine inverse is not capable of giving you an obtuse angle. Okay. Now, as we go ahead and we start looking at some of these problems here, it's possible that we could end up on the unit circle, but it's probably more likely that we're going to be on the unit circle where the radius doesn't equal 1. So we got to be real familiar with these special right triangles here, the 45-45-90 and the 30-60-90. We have to know the relationship between the 3 sides. Okay. The shorter side in the 30-60-90 is always across from 30. If I want the longer leg, I'm going to take the shorter leg and multiply it by the square root of 3. And if I want the hypotenuse, the radius of the circle, I'm going to take the shorter leg and double it. Okay. 2x has to be across from 90 because it's the longest side. And x squared of 3 has to be across from 60. And if it's a 45-45-90, this is the only isosceles right triangle we have. So the 2 legs have to be identical. If you want the hypotenuse, you take the shorter leg and multiply it by the square root of 2. Now, even if you're not able to recognize it as a special right triangle, you still have the Pythagorean theorem. So you should be able to go ahead and figure out what that is, right? Okay. All right. So with that in mind, let's take a look at some examples. Now, we're not going to do these in any particular order. I'm going to go out of order, and there's a reason for that I'll talk about in just a second. But let's start with B. Okay. Briley, what do you think? Okay. So I have sine inverse of a -1/2. Isn't that right, Macy? Okay, if your eyes are closed and your head is down, let's get them up. Okay. So now sine inverse of a -1/2, this is going to equal theta. Now, especially in the beginning, maybe it's not a bad idea to go ahead and write down some extra information because you really want to know as much as you can about this. Sine inverse can only be evaluated with a ratio. So theta is the angle that I'm trying to find here. And maybe one thing that'll help you out, right, Cameron? Is if you go ahead and write the original statement. So maybe we could go ahead and say sine of theta is equal to a -1/2. You don't have to do that, but if you force yourself to write this stuff down, it's going to help you retain it more. Okay. All right. So sine inverse of a -1/2. I know that sine inverse can only be in quadrant 1 or quadrant 4. It can never be in quadrant 2 or 3. But how do I decide where I'm going to draw a triangle? Does anybody have an idea? Gabriel, what do you think? There's something about the 1/2. What is it? No, you're getting ahead. Right now we're just trying to figure out what quadrant I should draw the triangle in. Quadrant 1 or quadrant 4? Here we go. Think about this. Does anybody remember what trig function, sine, what variable is that? Was it x or y? Edward? X or y? I'm sorry? Is sine y or x? Y. Okay, sine is always the y variable. Okay, so think about it. If you have a value of y in the first quadrant, what sign is it? Y in the first quadrant is positive. Y in the fourth quadrant is what? Negative. That's how you decide where to put your triangle. You use the sign of the ratio you're given. So is this a positive or a negative 1/2? Negative. Because it's a negative 1/2, I'm going to draw a right triangle in quadrant 4, and I'm always going to make it perpendicular to the x-axis. Okay. Now, is everybody okay with how I decided what quadrant I'm going to draw that in? Okay, Gabriel? Because it's the negative 1/2. It's because of the negative. Now, if this had been sine inverse of 1/2, I'd be drawing it in quadrant 1. You choose the quadrant based on the sign of your fraction, your ratio. Okay. Well, what is sine's ratio? It's what over what? Ooh. Okay. All right, folks, we're almost 2 months in. If you are still struggling or do not know what the ratios for your trig functions are, that is something you need to take care of like immediately. Okay, you will not be able to move forward if you don't know this information. Okay, sine is always y over r. If I ask for any ratio, you need to be able to give it to me like that. Okay, so it doesn't matter what you got to do to make that happen. Okay, memorize it, whatever, get it done. Okay, I have a lot of students coming in for tutorials, and I'll ask them, "Hey, what's cosine's ratio?" I don't know. You can't do this unless you know the basic information. Okay, you got to take time. You got to practice, folks. Okay, and if you don't, your grade's going to reflect that. Okay, and guess what's happening next Friday? It's the end of the 9 weeks. Your last grade is on Wednesday, so some of y'all might want to wake up and pay attention, especially the folks who I keep having to call on. I'm just throwing it out there. Okay. All right. So if it's y over r, that means the radius is 2. So that means y is what? What's the only other value left in the fraction, folks? Y'all need to start speaking up. Get engaged with the lesson. Max, what is it? -1. Okay. The radius will always be positive, no matter what. Okay. Now, here's the thing. I've got a radius of 2. I've got a leg of -1. What do you think this is? 30/60 or 45/45/90? Can anybody tell me what that final side is? Close. Now, square root of 2. Let's run through the Pythagorean theorem. Let's say we don't know what that missing side is. A. What's Pythagorean theorem? A squared plus b squared equals c squared. Okay. So let's say a squared plus -1 squared is equal to 2 squared. All right. So I'm squaring a negative. That's going to give me a what? Positive. All right. So a squared plus 1 is equal to 4. So a squared is equal to 3 when I subtract. So what's a? A's got to be the square root of 3. So I'm going to come on over here. I got the square root of 3. Now remember, if you draw a triangle, it has to be one of those 2 triangles that we just discussed. Which one can it absolutely not be? Why can't it be the 45/45? Yeah, the 2 legs have to be identical if it's 45/45. So this one here is a 30/60/90. Okay, specifically, This angle right here, this is the angle that I'm trying to find. So we know it's a 30, 60, 90. The only question is, what's that angle? Is it 30 or 60? And how do we know? 30 or 60? We got a 50-50 shot. That's okay. That's a good question. How would we know? Cameron, how would I know if I should put a 30 or a 60 there? Tell me. It's 60. Why? Okay, it is not 60. Okay, Felipe, it's got to be 30. Why? Okay, because you kind of trailed off there. You said something about X, so I didn't hear you. It is 30. Michael, can you tell us why? Is that what you were trying to say, Felipe? Okay. 30 is the smallest angle in this triangle, right? So it has to be across from what side? The shortest side. 1 is shorter than square root of 3. If you were to put that in the calculator, you're going to get about 1.73. So the longer leg has to go across from 60. Okay, so I've identified what type of triangle it is. I know the angle. Remember, to get the answer, you always have to rotate from standard position. So it looks to be, in this case, I'm going to say that theta is equal to 30 degrees, but as a radian, that would be pi over 6. But there's something missing. Sophia, why? There you go. How did we get into quadrant 4? How did I rotate? We rotated clockwise. Remember, when you rotate clockwise, it's a negative. So that's a good rule of thumb. If sine inverse is in quadrant 4, guaranteed your answer will be negative. Keziah, what do you think about that? Keziah, why don't you go ahead and get the pass and go get yourself a drink of water because you need to wake up. You got water? Chug it. Okay. Because I'm going to tell you, that's twice. There won't be a third time. You get me? Okay. All right. There we go. Questions. Okay. Huh? I guess I'm not understanding the question. Oh, why is it 2? Because we compared the fraction I was given to the ratio for sine. So I know that r is 2 and y is negative 1. Just like we've done before, I get that information immediately from the ratio. Okay. So let's try another example. Yeah. The smallest side across from 30? Yes. Now, will it be that value? Maybe, maybe not. So we're talking about circles now of different radius lengths. Because see, think about it, the big picture, this radius is 2, so imagine this point right here is a point on the circle. We're just not looking at the circle itself. The circle is going to look something like that, just like we did before. Okay. Now, let's try C. So that one took us a little longer because we were going through the whole process, but now let's try C. You talking about when I labeled them? X is horizontal and Y is vertical. That's how I knew. Oh, because 30 has to go across from the shorter side. 1 is smaller than the square root of 3. Okay. So if you have square root of 3 and square root of 3, you would change it, yes. Yes. Okay. Exactly. Okay, let's try C. So sine inverse of the square root of 2 over 2. Okay, so I'm going to say this equals theta. Okay, so we plug in a ratio to the inverse trig function to get out an angle answer. Okay, now if you want to write the original statement, you're more than welcome to. So sine theta should equal the square root of 2 over 2. Okay, so let's see here. Who haven't I talked to today? Ashley. Okay, sine inverse can only exist in quadrant 1 or 4, never 2, never 3. Where should I draw my triangle? 1 or 4? Wait, what? Why 1? We did 4 in the last one. There you go. If you have a positive ratio, it goes in quadrant 1. If it's negative, then you draw your picture in quadrant 4. You choose the quadrant based on the sign, positive or negative. Okay, so I'm going to draw a triangle right here. So this is the angle that I'm looking for, theta. Okay, what's sine's ratio? Okay, we just said it. It was what? Y over R. So in this one as well, what's the length of the radius, the hypotenuse? 2. What's the vertical Y? Square root of 2. Anybody tell me what that third side has to be? Gabriel. It has to be square root of 2. It's one of the 45, 45, 90 triangles. So let's take a step back. Let's say you don't know what that is. See, this is why it's so important to be familiar with the special right triangles, because it's going to save you time. But you can still use the Pythagorean theorem if you want to. So a squared plus b squared is going to equal c squared. What happens when I square a square root? Yeah, so the square and the square root cancel. So a squared plus 2 equals 4. A squared equals 2. So yeah. Now I'm going to go ahead and take the square root of 2. Perfect. So that means that this has to be the 45, 45, 90. Okay. Now remember, we always must rotate from standard position. So if I rotate here counterclockwise to the hypotenuse of my triangle, well, I can see that the angle answer I'm looking for is 45 degrees, but I want it in radians. So pi over 4. Okay. Questions? Good. That's the answer. So pi over 4 is your answer because I want these in radians. I want your final answer in radians. Okay. See, that one went a lot quicker because we already kind of have the template. We kind of have a step-by-step knowing what to do. Okay, so let's try A. Sine inverse of 1. Okay, so I'm going to do the same thing I've done on every other problem. First, I'm going to say this equals theta. Okay, what we're plugging in is a ratio. The answer I'm going to get out of that is the angle. Okay, if I want to write the original statement, then sine of some angle theta should give me 1. Okay, again, you don't have to do that, but it really helps you and it keeps track of what you're doing. Okay, now, the first problem I notice is that 1 isn't even a fraction. So how do I solve that problem? Yeah, if you want to make anything a fraction, put it over 1. Okay, so now I have a y value and an r value because we're still working with sine, right? Okay, remember, sine inverse can only go in quadrant 1 or quadrant 4. Never 2, never 3. Okay, so Braden, what quadrant am I going to draw my triangle in? Why? There's no negative, it's positive. If this same problem had been sine inverse of -1, I'd be drawing my quadrant and triangle in quadrant 4. Yes. So this is the angle theta that I'm looking for. Okay, now we're going to go ahead and fill it in just like we did before, but I'm noticing some faces, so you're working a little bit ahead of me, so I notice people are already seeing a problem. What's the radius? 1, so that's the hypotenuse. What's y? 1. If I were to run through the Pythagorean theorem, what am I getting for the third side? 0. Okay, can we have a figure where one side length is 0 units long? Doesn't make sense, right? Does that mean we did something wrong? Can anybody tell me what kind of problem is this? If you can't draw a triangle for this exact reason, it's a what? Big word starts with a Q. Felipe? Quadrantal. This is going to be a quadrantal. What does that mean? What's a quadrantal? That means it stops on a what? An axis. So now for sine inverse, there's only 3 possibilities. Either my answer is negative pi over 2, 0 radians, or pi over 2. Because remember, sine inverse can only exist in quadrants 1 or 4. So kind of think of those 3 axes as the boundaries for those quadrants. Okay. Well, how are we going to figure out what is the answer? Look at the ordered pairs of that location. For example, at negative pi over 2, you have the ordered pair 0, 1. Again, it's tying back to the unit circle. Everything goes back to the unit circle. What's the coordinate at 0? Oh, 0, 0 is right here. Remember, what's my radius? So it would be 1, comma 0. What about this one right here? 0, 1. Okay, now here's my last hint. Sine is the y variable. Okay. We want sine inverse of 1. How does that help me figure out which one's the answer? That's exactly right. Say that louder for everybody here. Whichever ordered pair has the y equals 1 that we're looking for. Okay. So I'm looking at all of these. Oh, I forgot to put a negative on that one. So y equals negative 1 here. It's not negative pi over 2. Y equals 0 there. It's not that. Y equals 1 there. Theta has to equal pi over 2. Okay. Questions. Okay, like everything, it takes a little bit of practice. God, it's a practice. You gotta take time outside of class for this. Now, D, we're gonna go ahead and skip right now. We're gonna be doing this tomorrow because this one's not going to result in a special right triangle, and it's not a quadrantal. So we're gonna be measuring this by hand using a protractor. So you're the one class that this is really important to. There have to be some people who go out and get your own protractors. For a class this size, I do not have enough protractors for everybody. Okay, so I'm hoping that people will go get some protractors. Otherwise, we're going to have some folks who are just going to have to kind of follow along tomorrow. Okay, so please, 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 if you have a protractor, please bring it. If you have the time to go get one, please go get one. During tutorials, yeah, but only on Tuesdays and Wednesdays. True. If you want to do that, you can. Okay, but you're going to have to contact your swim coach. Okay. All right, so this is what we're going to be doing tomorrow. All right. Now, before we take off, I want to go ahead and show you inverse cosine. Okay, why it's going to look the way it does. Okay, so first we want to go ahead and plot the graph. So cosine starts with a 0. Maximum 0, minimum 0, all the way through. Okay. Oops. I'm stuck on sine inverse. Good Lord. Okay, maximum 0, minimum. There we go. That looks better. Okay. So now we're going to run through the same questions. Is this graph 1 to 1? What does that mean? X and Y? Y. There we go. 1-to-1 is referring to the horizontal line test. It fails. It is touching it in 2 or more places at once, so that means y values repeat. So right now, if I took the inverse, I'm not going to end up with a function. I'll have an inverse relation, which is just a bunch of points, but not a function. Okay, so let's start here. What's the range for this graph? How low and how high does it go? Okay, so everybody agrees vertically it exists between -1 and 1? Now to answer the next two questions, we're going to go ahead and choose points closest to the origin. For example, what domain value, what x, will give you a range value, y, of -1? So we're going to use this point right here. It's pi -1. So pi is the x value that will give me a y value of -1. Okay, what domain value, what x, will give you a range value y of +1? We're going to use this point right here. What's this location? Now, what's the coordinate of that point right there? 0, 1. Okay. So let's say where they intersect is, of course, 0. We'll say this is pi right here, and it goes between 1 and -1, just like the previous graph. Okay, so let me go ahead and put 0 right here. Now, just like the previous one, this is not 1-to-1. So I'm going to go ahead and cut parts of it loose so that what's left is a 1-to-1 function that'll give me an inverse that I'm looking for. Okay, so I'm only going to allow it to exist between 0 and pi. So here's my domain. The domain is everything from 0 to pi. The range, we already said, is everything from -1 to 1. Okay, remember, what are we doing with the x's and the y's? We're switching them. So I can already predict what the domain and range are going to be for cosine inverse. Cosine inverse of theta. Okay. The range of the original function is going to become the domain of the inverse. So I know down here the domain is going to be everything from -1 to 1. What's the range going to be? 0 to pi. All I'm doing is I'm switching those. The x's become the y values and the y's become the x's. Okay. So if you take a look horizontally, you'll notice we have 0 and pi. So on the inverse, those are going to be vertical. They're no longer horizontal. So let's say we have 0 here. Let's put pi right here. Vertically, you see we have -1 and 1. So those vertical values, they're now going to be horizontal. So let's say -1 right here, +1 right here. Okay. Now, let's flip those points. For example, if I have a point pi -1, then down here it should be -1 pi. So -1 pi will be on that graph. What's the inverse of 0, 1? 1, 0. Okay. And remember that it has to reflect across your linear parent y equals x. So from this point to this one, it's going to curve like that, so it's going to form another really skinny figure 8. So this is what cosine inverse is going to look like. Okay. So we had to restrict it. We cut away part of its graph so that this is now a function. I can answer some questions. Okay. Now, this is how we'll finish up today. Right? So here's cosine inverse of the ratio equals the angle. Okay, so the domain, the ratio can only exist between -1 and 1. Okay, has to be between -1 and 1 for this to even work. The angle has to be between 0 and pi. Now, cosine inverse is capable of producing an acute angle, a right angle, or an obtuse angle. That's a huge difference from sine inverse. Sine inverse is not capable of giving you an obtuse angle. Okay. cosine inverse if. But sine inverse is also capable of doing something that cosine inverse can't. Anybody know what I'm referring to? The very first problem we worked, what kind of angle did we get? Part B, no, that was A. What did we get in part B? What's that? No, A was the quadrantal. Part B on sine inverse, the very first problem we did, what kind of angle did we get? A negative. Sine inverse can give you a negative answer. Cosine inverse cannot. Okay. Now, because our angle has to be between 0 and pi, cosine inverse can only exist in 1 and 2. Cosine inverse can never exist in 3 and 4. Okay. And then, I mean, we're using the same triangles. Okay. So the ratios and those special right triangles, we need to have those memorized. Okay. Take some time. Make sure you committed those to memory. It's going to be really difficult for people to move forward if you don't know the ratios. Okay. When you come in tomorrow, please make sure you're bringing your protractor. I will have a few, not enough for everybody, but we'll go ahead and take a look at some answers, or some problems, I should say. Okay, and that is it.